This lecture will explain the rule of arrow in, or arrow introduction. It's also called conditional introduction. And this rule has two versions. So in this lecture, I'm going to explain what I'm going to call version 1. And this is the one that you're going to use for the most part. So the way version 1 works is that, so if we want to derive some conditional P arrow Q, then what we do is we start out by assuming the antecedent, P, and we're going to justify that by saying A for assumption. In your text, they write out the word assumption, but that's not necessary. That's too long. So we'll just write an A. Then we're going to, from that P, and of course using our other premises, we're going to derive the consequent, Q. When we do, once we've done that, then we're entitled to say, aha, P arrow Q by arrow introduction. And we can say this because what we've done here is we have not asserted that P is the case. We've just said, what if P is the case? Well, if P is the case, then so is Q. And therefore, if P, then Q. And that's all there is to the rule of arrow in. Oh, I guess the other thing to tell you is that the rule of arrow in is justified by whatever line that consequent happens to be on. We don't need to say, that's all we need to say. That's just our convention. So we would say arrow in, line, star, whatever that happens to be. So let's look at a proof that uses this rule. So suppose we have the premise P arrow Q, and we have the premise Q arrow R and S. And what we want to create, so these are premises. And let's say our goal is the conditional P arrow S and R. Okay, so, obviously there's nothing we can do with lines 1 and 2 just as they are. They're conditionals, and we don't have the antecedent of either of the conditional. So we can't take them apart. So we want to get P arrow S and R. So we're going to need to do an arrow in proof to create this conditional. So we're going to start out by assuming the antecedent of the conditional we want to derive. That's an assumption. And I like to write why I'm doing it right next to the assumption. That's not technically part of the rule. You don't have to do it, but it's really, really useful because it reminds you why you're doing this. So you should never make an assumption if you don't know why you're making one. Okay, and so what we want to do is we want to derive S and R. We'll put a box around that. Okay, and once we get to S and R, then we can go, aha, P arrow S and R by arrow in. Okay, so now that we have P to work with, we can get Q out of line 1 by arrow elimination on 1 and 3, using 1 and 3. And now we can get R and S from line 2 by arrow elimination. So that's by 2 and 4. And then what we have to do, it's a little tedious, we have to take apart the R and S. So that's by and E on line 5. And then we put it back together again in the order that we want. So that's and introduction, 7 and 6. And then at that point we're done. We can say arrow introduction by line 8 because that's the line that contains the consequent here. And the proof is complete.